What's up, guys? My name is Rajat Sharma, and I welcome you once again to the physics video lecture series. We are talking about projectile motion. We were discussing projectile motion in the previous lectures, and in this lecture, I'll be telling you some general points regarding projectile motion, some general comments. So, general comments on projectile motion. Okay, so some of these comments are uh, might look very obvious to you. Okay, and this is the reason why I want to bring these points out. Okay, so that this is always there at the back of your mind, and you are not confused during the examination whether these points are valid or not. Okay, so it's very necessary to keep these points in mind. First is obvious that projectile motion is symmetric about the highest point axis. Now, obviously, I'm not writing it in a purely elaborate form, but this is very much obvious. And when I'm making these comments, I'm talking about the projectile which has been thrown from the ground and receiving back on the ground. I'm not talking about projectile which has been thrown from a certain height or projectile on an inclined plane. Okay, so please bear this mind. So this is the highest point, and highest point axis means an axis passing through the highest point. So obviously projectile motion is symmetric. So this region to the left of the axis is same, okay, to the region right of this axis. Now when I say same, what does it mean? So when I say symmetric, this is the points that come to your mind is that this length will be equal to this length. Since the total is r, so this length will be r by 2, and this length also will be r by 2. The area of this region will be same as the area of this region. Now area does not play any role in the calculations as such, but yeah, we are talking about the symmetricity, so I thought I should talk about area also. Another important thing is time. Okay, so time taken to go from the starting point to the highest point, let us call this t1, and time taken in going from the highest point back to the uh, final point, and call this t2. So t1 will be equal to t2. Let us call this x1 and x2. So x1 is equal to x2. Okay, so this is the meaning of symmetricity. Now I can make further comments as well. So if I take this projectile, and suppose I take any general point at a distance of x from the starting point. Being symmetric also means that if I draw a horizontal line from this point, it will strike the trajectory at some point b. And being symmetric, it means that this length will be x. If this length is x, then this length will be also x. Further, the time taken from O to A, let us say TOA, and time taken from B to F, let us say TBF, then TOA will be equal to TBF. You can clearly see. So this is also the meaning of symmetry. Okay, so these are some of the general points regarding being symmetric. What does it mean, and how you can use it in the calculations. Okay, it's pretty obvious. The next point that I would like to make regarding the projectile is that the range of projectile is maximum when theta is equal to 45 degree. And this is very, very obvious if you know a little bit of trigonometry. We know that range is equal to u square sine 2 theta upon g. Okay, this is the range. Now just think about it. If I freeze the initial velocity, g is a constant. If I freeze the initial velocity, obviously when you want to compare at what angle the range is maximum, so you have to freeze the initial velocity. You cannot increase the initial velocity for different condition. That will not be a valid comparison. So you are throwing at different angles. Let us say like this. So at what angle the range will be maximum? Considering that each of the throw is at initial velocity u. So u square by g is a fixed value, is a constant. So when r is maximum, when sine 2 theta is maximum. Okay, from the equation that we have now, maximum value of max value of sine 2 theta is 1, because sine varies from -1 to 1, so maximum value is 1. So this will be when 2 theta is equal to pi by 2, 90 degree, or theta is equal to pi by 4, which is nothing but 45 degree. So range is maximum when theta is 45 degree. This is also an important thing. Sometimes in the question they do not specify the angle. They will say that the projectile has been thrown for maximum range. So if they're saying like that, that the projectile has been thrown for maximum range, you have to assume that theta is 45 degree. Okay, fine. The third point, this is also very important. Range is same for two angles, alpha and beta, if alpha plus beta is equal to 90 degree. Again, assuming u is constant. So what does it mean? So suppose you throw a projectile with velocity u at an angle, let us say 40 degree, and if the range is r, then if you throw the projectile again with u, and I want that the range becomes same, but I want to throw at a different angle. I don't want to throw again at 40 degree, I want to throw at a different angle. Then you should throw it at an angle such that the sum of the two angles is 90 degree. So this angle should be 50 degree, because 50 plus 40 is 90. So if you are throwing a projectile at theta, the other angle should be 90 minus theta for the range to be same, considering that the initial velocity is same. And this is also pretty obvious how range is equal to u square sine 2 theta upon g. So u square by g is a constant. So if I replace theta with 90 minus theta, this will become u square by g sine 180 minus 2 theta. And from basic trigonometry we know that sine pi minus theta is sine theta only, so we will get sine 2 theta again. So isn't the same for theta? So if you are throwing it at theta, the range is u square sine 2 theta by g, and if you are throwing it at 90 minus theta, then again range is u square sine 2 theta by g. So the range is same for these two angles. Now I want to talk about a very important uh, method. Suppose you throw a projectile with u at an angle of theta, and you are